in this set of questions in functions, this is type 3 questions in our website. Here we have asked to find domain and range from given graph or expression. This is very, very simple. I'll explain you first before we even go to the question. Okay. Now see, this is our xy axis, x and y axis. Suppose I've got a straight line like this, straight line. A line has arrow marks on both sides. Does the line end? It doesn't end, right? So let's take this point. It has some x value and it has its corresponding y value. So here also it will have x value and y value. It will keep on going, right? The line is not ending. So I can go up to what point? I can go up to infinite, right? On this side, and I will get infinite values for y. Similarly, if I go on the left side, I can go up to infinity from here, correct? And always I will have y values also up to infinity. So domains is what? Domain is set of x values which we can input in a function, and range is the values of y which we get after inputting the values of x. Okay, right? So what is domain? Domain is values of x which we can input in a function. Okay. And what is range? The values of y. So range is y axis, domain is x axis. Okay, never forget this. Domain is the values which we can input on x, and range is the values of y which we obtain after we input values of x, right? I hope you understood, right? So in simple terms, because this is a straight line, okay, I will also tell you some shortcuts. A straight line, the domain and range will always be same. It can be any kind of straight line. It can be line like this, line like this, line like this, any straight line. Whenever there is a function straight line, how do you identify straight line in algebra? It will be like this: y equals to mx plus c. I'll give some example: y equals to 2x minus 3. So whenever you see something like this, it's a straight line. Okay. And whenever you also see something like this, 2x minus 3y minus 6 equal to 0, this is also a straight line, right? So whenever they give you function they will obviously give you in this format, because this is a standard form of an equation. It's not a function representation. Function, you should always have y on left side and x things on the right side. Okay. Now whenever there is a straight line function, the domain and range is same. What are the domain and range of straight line functions? I told you that x can take any value. So domain of a straight line function, domain, we will write domain D, and we will write negative infinity to positive infinity for straight lines. Okay, domain is always this, it will not change. Okay, it will go negative infinity to positive infinity. I will tell you some exceptions of straight lines where this doesn't work. And range is also negative infinity to plus infinity. What kind of straight lines? Which are inclined, which are having some slope. These kind of straight lines, not vertical and horizontal. Okay, when vertical and horizontal lines, also I'll explain. For line, suppose I give you line x is equal to 2. What does this line mean? That it's a line which is passing through 1, 2. Our line is this one, which is passing through x is equal to 2. Now this is also a straight line, but here the domain value, is it anytime changing other than 2? It's always 2. So in this kind of line, domain is x is equal to 2. only one value. So how we write? Can we write like this? We can write in a set builder form, right? We will write it like this. Domain is x such that x is always is equal to 2 and x belongs to real numbers. So this is a set of all real numbers where x is only belonging to where x is a set. Okay. So this is how you can write the domain. And what about range of this? You can go up to positive infinity and go up to negative infinity. So range of this value is negative infinity to positive infinity. Why we are writing square bracket? Because infinity you cannot include, right? If something is included, you will always put square bracket. Okay. You have understood? Now, because since we have discussed horizontal line, we will also discuss a vertical line. We will also discuss a horizontal line. Okay. I am explaining so that while doing the questions which are coming next, it will be very easy for us. Now, we will take horizontal line. Suppose it is passing through 1, 2, 3. So the equation of this line is y equals to 3. What is domain of this line? Domain, you see, y value is fixed, it is not changing. So that's the range, right? So domain can be minus infinity to plus infinity. Domain of this line will be negative infinity to positive infinity, and range is y equals to 3. That's it. Because no other value, only 3. Wherever you see this point, look at this point, it will have some x value, but y value is fixed 3. Look at this point, x value is some negative value, but y value still is 3. Y value doesn't change, so range is fixed here. Okay. So now we have discussed domain and range of straight lines which are inclined like this or like this. We have also discussed straight lines which are vertical, and then we have also discussed straight lines which are horizontal. Okay. So domain and range of this, right? What about parabola? Let us see a parabola now. Parabola, suppose I have a parabola like this, okay, where this is the vertex. I'll assume that this vertex is 2, minus 6, right? This is 0. So this point is 2 and this point is negative 6. Okay. This is a parabola, upward opening parabola. So it is a quadratic function, right? And there is arrow mark here and there is arrow mark here. Now, look, this parabola will keep on going towards left and right. This one will keep on coming right side. This one will keep on going to left side as it progresses upwards, right? So domain for this one is always minus infinity to plus infinity. For every quadratic function, domain is same, whether the parabola is inverted or upward. Okay, only two kinds of parabolas, either upward opening parabola or downward opening parabola. So domain is always same. Okay, but range, look at the range, look at the y value. Is the curve anytime coming below negative 6? No. So what is the y values? All y values are more than negative 6. It's going up only. So minimum value of the y is negative 6 and it can go up to positive infinity. So range, I would say negative 6, which is included, and it can go up to infinity. But infinity is not included, so I will write a round bracket. Understood about this? So range, see this curve. If I put a line, do you see the part of curve, anything? So y value is always more than negative 6. That's why negative 6 to positive infinity. Okay, understood? Very easy quadratics. So whenever you have a quadratic function and they ask you domain and range, domain blindly it is minus infinity to plus infinity. Range, you look at the vertex. Okay, either if you are going that side, it will be from here to infinity. If it is going downwards, then it is different. Okay. So let's do some questions from here in this type. Look at this, one more special case. whenever you have a function, you see this is an empty hole. See very clearly. We can have another one. See, this is a dark hole. Okay. When it is dark, that means that point is included. When it is empty, hollow, that means that point is not included. Okay. Now coming back to the question. Look at this. So here the function is, arrow mark is this side. So x can take any value. What is the minimum value of x here? -4. Is the function coming to beyond -4? No. Function is only going towards right side. So domain for this function, and -4 is not included. So I will write -4 in round brackets, and it can go up to positive infinity because it's arrow mark infinity. Okay. Right? Understood, right? The function is only going towards that side, and the minimum value of x is -4. It is, and that too not included, and function is not going that side. Now range is, see, the y value is not coming below -2, right? It's only going above -2. So I would write -2 also not included, and it will keep on going up to infinity to positive infinity. So that's the domain and range for this one. I hope you understood. Okay. For this one, here only difference is there is no arrow. Both sides are closed. The function has minimum x value and maximum x value. So I can straight away write domain is -3 to +4, both included. All values between -3 and +4, and y square brackets because it's a colored dot, the complete solid dot, not a hollow dot. So both numbers are included. And what about the range? Range is -5 is the minimum thing, and +2. Y value is +2. See, it is not going below this, and it's not going above that. Okay. Okay, so we have our domain and range. Understood, right? Now let's look at this one. Now here once again domain will be this time round brackets because the points are not included, empty. Which is the minimum value of x? -3. What is the maximum value? 4. And for range, what is the minimum value of y? -5. And what is the maximum value? 6. And both points are not included, that's why round bracket. Okay, understood? Doing this kind of question. Okay. We have few more, right? Now, this kind of question we discussed. Here, is x value changing? X value and this line will always be 2. So domain is x equal to 2, and range is -infinity to +infinity, correct? What about this? This is not a function because it's failing our vertical line test. See, when I keep the pen here, what happened? Yeah. When I keep the pen here, it is touching the circle at 2 points. So it is not a function, it's a relation. But it also has this domain range. What is the maximum value? Minimum of x is -3, maximum is 3. So let's write domain, and both points are included, -3 to 3. But you write not a function, not a function. Okay. And range is also from -3 to 3, and both points included. Okay. Easy. Now this is a quadratic function, it's a parabola. Okay. But vertex is, the vertex is 0, 0. But x values can take all values up to -infinity and up to +infinity. So domain, as I told you, it is for parabola, always it is -infinity to +infinity. Okay. And what about the range? Range will only take values from 0, right? So I'll write -infinity to 0. I write lesser value, -infinity is lesser, and maximum it can go up to 0. Okay, understood? So this is right. Pause the video if you want, or if you want to rewind and see, rewind and see. Definitely this kind of question will be there in your reassessment. Few more questions we have here. For here, this is our function, this one. This is origin, right? So domain, it's a horizontal line. Domain can take minus infinity to plus infinity, minus infinity to plus infinity, but range is simple thing. It is y is always equal to -5. It's not changing, the fixed value. Okay. Now parabola once again. So domain will be once again minus infinity to plus infinity. As I told you, quadratics domain will always be same. Vertex, for range you have to see vertex. The minimum value of y is 1 and it's going only in the up direction. So I will write 1 to positive infinity. Okay. Because the minimum value of this is 1 and it's going upward only, right? So it is 1 to infinity. Now here, this is, you have to watch, okay? This is a peculiar thing because they are given 2 dots. It's like a cubic function, but again the function has its terminating point at -5,7. So look at what is the minimum value of x. For such complex figure, look at minimum value of x. I don't see x coming beyond -5. -5. So let's write domain. -5 is included, right? -5 is included. It's a solid dot, not a hollow dot. -5 is included, and it is moving towards the right side, and it will keep moving towards the right side. So we can write it will end at infinity. Okay. Now for range, many people look at this point. No, 7 is also included, right? All values 7 and below. Okay, don't look at this, right? This is for confusing you guys. So range is -infinity, lowest value, and maximum value of this one can be 7. So we write lesser value first and the maximum value, and both value. Oh yeah, 2 mistakes I did here. When we write infinity, it should be round bracket. When we write infinity, it should be round bracket. Okay. Be very careful. Infinity cannot come under, because can you have infinity? You can't include, so it should always be in round bracket. So these questions are done. Now 3 more are there. Let's see quickly. For here, the domain will be parabola. So domain will be -infinity to plus infinity. What is the range? The maximum value of y is 4. So, and it will go up to -infinity to 4, but 4 is included, right, round bracket. This is not a function because it fails the vertical line test. It is touching the 2 points. So write not a function. Typically, when it's not a function, we don't write the domain and range. But for relation, if they say find the domain and range of this relation, right? So we can write domain is x coming below -5? No. So -5 is included and it will go up to positive infinity, and range here it is -infinity to plus infinity. Okay. I hope you understood about this. What about this? This is definitely a function. It's a reciprocal function. See, it will only touch at one point when I am moving my point. But look at this. At this point, the function doesn't touch this value, and function doesn't touch the x-axis also. Okay. So what we have to be careful here, domain, you can straight away write, it is better to write in set builder form x such that x is not equal to 1, where x belongs to all real numbers. This is better way of explaining this instead of this, because here is a continuous thing, here is discontinuous, because the set is discontinuing at x equal to 1. So it is better to write in this fashion. And what about the range? So y will never be 0, but it has -infinity to plus infinity. Y such that y is not equal to 0, where y belongs to all real numbers. So this form is better form of writing for discontinuous functions, because function is breaking at x equal to 1. Okay. Now we have got expressions where we have to write only the domain. Only the domain. fx is equal to 2x, right? It's a linear thing. So domain will be negative infinity to positive infinity. This is a reciprocal function, right? Now for this kind of function, you should always remember that this function will be something like this. The x for domain, x will never touch, the function will never touch x-axis, nor it will touch y-axis, right? So I will write domain is x such that x is not equal to 0, where x belongs to set of real numbers, and range y such that y is also not equal to 0, y belongs to set of real numbers. Okay, right? Although they didn't ask the range, but I still written. Okay. For C, what is the set of domain? Very simple. This should not be 0. If denominator is 0, the function does not exist. So pick up the denominator, x minus 3 equal to 0, x equal to 3. So if x is equal to 3, function does not exist. So in what we should write domain? That x should not be equal to 3, because the moment x is equal to 3, the function does not exist. So we can write domain here, x such that x is not equal to 3, but x can belong to all other real numbers. Okay, so that's the domain for this particular function. Okay, next one. Here, root x minus 2, if it is, right, now let us see this. Root of x minus 2, if it has to be real number, it cannot become negative, right? So that means it is more than, it should be, so what we should write? X minus 2 should be more than 0. Then only it is a real number, because inside root, if you get a negative number, it is not a real number, it's an imaginary number. So x minus 2 should always be more than or equal to 0. Equal to 0. More than equal to 0. Therefore, x is more than equal to 2, right? So how we can write domain for this one? Domain is x such that x is more than equal to 2, where x belongs to real number. That's your answer for A. Okay. So whenever roots are there, you have to be very careful. For B, what will we do? For B, we will write, for B, our rough work will be 3 minus x should be more than equal to 0, right? So I can write this one, I can take x there. X should always be less than equal to 3, right? So I can write the domain here, x such that x is always less than equal to 3 and x belonging to real number. Okay, clear? Now here it's a double thing, root of x and 2 minus x. So for this one, x should be more than equal to 0, one of them, right? And here x cannot be less than 2. X cannot be less than equal to 2, right? X should be more than equal to 2. We should write x should be more than equal to 2 or more than equal to 0 and more than equal to 2. So we'll write domain, because it's more than 0, we can straight away write, we can use this domain, we can write x such that x is more than equal to 0, where x belonging to real number, right? But look at this, if it is 0, if I put 1 here, 1, it becomes a imaginary number. So we should not take this one, we should take this value, because both conditions should satisfy. So this one becomes wrong. Our correct answer should be x such that x is more than equal to 2 and x belongs to real number. This is a condition. So that's the domain for that particular thing. Okay, understood? So with this, we come to end of this particular